Let's see the next question in this exercise. A TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite to the tower, the angle of elevation has been given as 60 degrees. From another point 20 meters away from the first point, the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degrees. So there are two distinct points involved. So this will be involving two separate right angle triangles. We are supposed to find out the height of the tower and width of the canal. The diagram is given in the exercise. So let's see that this line represents the ground and the tower is on one side of the one bank of the canal. So the TV tower height is unknown. So let's call it as H, and obviously it's at 90 degrees. Now, this is the canal. This part is kind of confusing, but the width from the foot of the TV tower to this point is actually canal. So if you go to the other bank, which is directly opposite to the TV tower point corresponding to the opposite side of the bank, that will be this point. And then from that point, the person walks another 20 meters away from the canal. So, and the two angle of elevations have been given as 60 degrees and 30 degrees. The distance between these 2 points, equivalent of the first point walking to the second point, has been given as 20 meters. So what exactly we want to know? We want to know the width of the canal. Let's assume that as X, and height of the TV tower has been asked to. Let's assume that as H. Since this involves two triangles, we have to use the trigonometric analysis twice, just like in the previous exercises. Most likely we will use the same trigonometric ratio for both the situation. Let's see. First, I'm going to consider smaller triangle, and for this 60-degree angle of elevation, this TV tower is representing the side opposite to it. Canal represents the side adjacent to it, and the hypotenuse is this line, which is probably not really important in this scenario. So we are trying to correlate H opposite and X adjacent. Now both of them are unknown, which is fine. Unlike previous couple of questions, one of them was known and we were directly using the standard trigonometric value. But here both are unknown. There is absolutely no need to worry because we are going to do this analysis one more time and we will get one more equation. So we'll have two equations with the unknowns and we will try to manipulate somehow. So let's try to do the analysis of the first smaller triangle completely. We are correlating opposite with adjacent. So we are going to use tangent trigonometric ratio. We are going to write tan of 60 is opposite over adjacent. In this case, tan 60 is √3 standard value. Opposite is TV tower H and adjacent is the width of the canal, let's say X. So you'll get an expression √3 equal to H divided by X. By cross multiplication, we'll get H equal to √3X. Now, we'll keep this as it is for the time being. We are going to revisit this equation once we get more information from the analysis of bigger triangle. So now let's forget about this triangle and now consider the bigger triangle. For this case, the opposite is for 30 degrees. That is still TV tower, that is still H. But now the adjacent is the complete distance, which is X plus 20. So we are going to use the, again, tangent ratio because we are correlating opposite with adjacent. So tan of 30 degrees is opposite over adjacent. Opposite is still H, adjacent is X plus 20. However, now tan 30 is standard value 1 over √3. So we are going to write down 1 over √3 equal to H plus X plus 20. Now, if you do the cross multiplication, X plus 20 times 1, which is, oh, by the way, since I have two unknowns, I don't like that. So I'm going to replace one of them. So H is already √3X. So I'm going to replace H by √3X. Now I will do the cross multiplication. X plus 20 times 1 will be X plus 20 as it is. And √3X times √3, this diagonal will be √3 multiplication will give you 3X. X will be substituted, replaced and sent to another side. So that will be 2x equal to 20 and x will be 10. So the width of the canal is actually 10 meters. That's just one of the answers. Now I'm going to use this 10 meters and I'm going to revisit the equation which I have left there. And if you substitute the value of x, h will be root 3 times x, which is root 3 times 10. So 10 root 3, the units will be in meters. So they had asked you two questions. Height of the tower, that came out to be 10 root 3 meters, and width of the canal, that was x, that came out to be 10 meters.